Alright, now we're going to look at some questions that use the quotient rule. Again, you'll notice that splitting a fraction or trying to simplify with my exponent rules will not help me, and so definitely the quotient rule will be the simplest way of doing it. So we have y equals sine of 2t over t squared. And I notice that inside of my sine function, I have an inside function, which means that I actually have a quotient rule and a chain rule. And I'm going to let u equal sine of 2t and v equal t squared. Now my u dashed, I'll be using my chain rule because I'm going to have cos of 2t multiplied by my derivative of the thing inside my brackets, so it's multiplied by 2. That becomes 2 cos of 2t, and my v dashed will just be 2t. Okay, so my y dashed is going to be u dashed v minus v dashed u, the v squared, and that means I have 2 cos of 2t multiplied by t squared minus 2t times by sine of 2t and I'll divide that by t squared all squared. So I need to tidy that up a little bit. I have 2t squared cos of 2t minus 2t sine of 2t over t to the 4, and I can tidy that up a little bit because I can take out a t and I can cancel that. So I then could have, let's take out a 2t and I'm left with t cos of 2t minus sine of 2t over t to the 4. And I can cancel out 1t, so I've just got 2t cos of 2t minus sine of 2t over t cubed. Okay, let's have a look at the next one. Now when I see a question like this, and it says determine the gradient at the point x equals 0, that tells me that I probably don't need to try and spend time simplifying and factorizing, because the aim of the question isn't to see whether I can simplify and factorize, it's more to find where the gradient at the point where x equals 0 and what that is. Okay, so again I have a quotient rule because I have a division, but at the same time I have a chain rule as well. Remember to always quote both the chain rule and the quotient rule. So we have f of x equals cos 3x over 2e to the x take x. And I'm going to say using the quotient and chain rule. And I'm going to let u equal cos of 3x and v equal 2e to the x take x. My derivative will be negative 3 sine of 3x, and here my derivative will be 2e to the x take 1. Alright, so my derivative is u dash v minus v dash u over v squared, and that will be negative 3 sine of 3x multiplied by 2e to the x take x minus 2e to the x take 1 cos of 3x divided by 2e to the x take x all squared. I can simplify that a little bit before I try and do my calculations, because I can take, is it going to be worth even doing that? Possibly not. So let's find the gradient when x equals 0. We have negative 3 sine of 0 multiplied by 2e to the 0 take 0 minus 2e to the 0 take 1 times cos of 0 over 2e to the 0 take 0 all squared. And that gives me sine of 0 is just 0. So that whole first term is just 0. But cos of 0 is 1. Okay, so we've got negative 2 take 1, which is just 1, over 2 squared for